Flywheel dowel pin removal with the snap-on dowel pin tool. Find the right sleeve to fit over the dowel pin. That one's too small. This one's just right. And this one is a little bit too large. Put the sleeve inside the collet. It's slotted so it fits just one way. Then put the forcing screw pin down into the sleeve and over the pin. Now tighten the screw. This locks it onto the pin so it holds onto the flywheel. Now grab the slap hammer screw and the heavy weight that slides on there. It only goes on one way. Screw this into the forcing screw. Then use a slap hammer to remove the pin. When you're done, you have to remove the dowel pin from the collet and the tool in order to remove the other two dowel pins. Unthread the slap hammer. Loosen the forcing screw. Tap out the collet and remove the dowel pin. Now, repeat this process for the other two dowel pins. When you're done, the dowel pins will be removed and the flywheel will be smooth. Flywheel preparation, measurement, and setup. First thing we want to do is we want to clean the surface off. I'm going to use a little sandpaper here just to smooth it out. Then I'm going to clean the surface on the machine. Also, clean the surfaces on the spacer plate. Set the spacer plate on the flat surface of the machine. Then place your flywheel in position. Locate the correct cone and the bolt to mount the flywheel to the machine. Use the Allen wrench to tighten the bolt. The flywheel will move around. We will center it later. First, we want to measure the step height on the flywheel. Here I'm going to use a depth gauge with a couple of extensions and a flat bar to measure that step height. First we're going to measure the height. Then we slide the bar over to measure the outer surface. Here we hold it carefully and we note that we have a 17 thousandths of an inch step. As I move the dial indicator back, we'll notice that we move back to a plus 2 thousandths of an inch. This gives me a total step depth of 19 thousandths of an inch. We must maintain this step when we resurface the flywheel. Now we need to center the flywheel onto the grinder. We're going to use the outside surface as our designated area for measuring the runout. I'm going to use a little sandpaper to clean off the outer surface first. Then I'm going to wipe it off with a rag before I set up the dial indicator. Place the dial indicator on the outer surface. But first I need to loosen the adjustment so the flywheel moves around, and then just snug it up a little bit so I can bump it into the position that I need it. Preload your dial indicator and rotate the flywheel to measure the runout. Find your high spot and with the palm of your hand bump the flywheel back about half the amount of movement. Recheck the runout. Zero your dial indicator and check it one more time. Once again, find the high spot, use the palm of your hand to bump on the flywheel to reduce that movement by approximately 50%. Zero your dial indicator again and measure a run out. Here you will see that when I'm done, I will have approximate run out of about 1.5 thousandths of an inch. This is clearly smooth enough to resurface my flywheel. Now, put a final tightening on the lock screw and remove your dial indicator. Flywheel surface reconditioning. Here on the machine, we have the controls that raise the motor or the grinding wheel up and down. There's a micrometer that shows up here. However, it's not too accurate, so I've got my own setup on the side with a dial indicator. Over to the right are the controls. This turns on the coolant flow, this turns on the rotation of the table, and this is the grinding motor. With the motor turned on, you can see the table going around.
Move the table in and out.
This crank moves the table in and out.
Move it in.
That positions it at the grinding wheel.
Turn on my coolant.
Turning on the coolant, making sure that the coolant is spraying right on the grinding wheel and on the stone. Place the splash shield over the unit. Turn on the grinding wheel.
And we will slowly bring the grinder head down.
Slowly turn the grinding wheel head down till it just barely starts to touch the flywheel. This is what's called the scratch cut. Now we want to zero our dial indicator so we know how much we've moved that grinding head. Now slowly bring down the grinding wheel until it starts to cut onto the flywheel. You'll proceed in this manner until the grinding wheel has made a clean cut all the way across your flywheel. Slowly turning the head down a little bit at a time. Once you got a nice clean cut, you can raise the grinding wheel up and check the step height. Here I'm measuring 14 thousandths of an inch. The original was 17. That means I have removed 3 thousandths of an inch off of the surface of that flywheel. I now must remove the same amount from the outer edge of this flywheel. Reposition the grinding stone. Making sure that it lines up so it will only cut the outer edge. Turn on the table, turn on the coolant, and turn on the grinding wheel. Now slowly bring the head down to take another scratch cut. Once you have a scratch cut, zero the dial indicator that measures the height of the table movement. This will help ensure that we don't take too much off. Slowly turn the grinding wheel so that the head moves down and starts to grind from the flywheel. Continue with this process till you have a nice clean cut all the way around. We can now compare the table height movement, and we can see that it's approximately the same as what we did for the previous surface. Now raise the table up so you can remove the grinding stone from the flywheel.
Turn the grinder off.
Turn the table off,
Turn off.
raise the grinding stone, and check your measurement.
Move the table up.
We still have the minus
Move it
2
over
thousandths
to
of an
the
inch,
Step.
and with our new cut, we now show 17 thousandths of an inch, meaning we have the same amount from when we started.